It is important to remember that absolute value represents distance. And because it represents distance, it can't be negative. So it cannot be negative. Distance is never negative. That just doesn't even work. It's not a thing. So we're going to solve these. We're going to give every solution. So basically, I want to know all of the x values, all of the numbers that are 3 units away from 0 on a number line. You could think of this as like a number line. So here we go. Let's number line this thing. So there's 0, 1, 2, 3, 1, 2, 3, -3. And the answer is going to be fairly obvious. The absolute value of x equals 3. So let's put it in terms of this kind of idea right here. So give every solution. Tell me every number that is 3 units away from 0, because that's where we start, from 0 on the number line. So everything that is a distance of 3, 1, 2, 3. Okay, so final answer here, and I'm just jumping straight to the final answer. Final answer is 3. But it also could be 1, 2, 3, because it's 3 units away. I had to go in the negative direction. So 3 or -3, yes, you could do plus or minus. So here's the deal. If I have absolute value, I have the possibility of getting 2 different answers. In this case, I could get 3 or -3. Because, and we can check our answer this way, you could be like, the absolute value of 3 is 3. Yay, it works. The absolute value of -3 is 3. Yay, it works. So we know what x could be. It could be a couple different things. Okay, why is there a graph here? Check this out. This is so cool. This is so neat. I'm going to graph each side of the equation separately. Totally valid way of solving this thing. So if I graphed y equals the absolute value of x, and I'll graph it in purple for no reason, then I would have this parent function that you are quite familiar with. I'm going to draw it perfectly with the slope being 1 on this side and a slope of -1 on this side. There we go. And now I'm going to graph the other side of the equation as y equals 3. Just graphing it, and just y equals this side, y equals that side. Don't make it harder than it is. So y equals 3. So the line y equals 3 is a horizontal line at 3. So there it is. That's it right there. I'll put little arrows just for fun. We'll do the same thing with the purple graph. Okay, so the answer to the question would be the x values, because that's what they're asking for. So the x values where they intersect. And at each point of intersection, we're going to have a specific x value. In this case, x equaled 3. In this case, x equaled -3. Isn't that neat? So you're probably like, wow, I already knew the answer. That was obvious. But this strategy is going to come in handy later when we're doing something that might not be quite as easy. So let's move on. And for the next one, I'm going to do the same idea. Now, you probably already know the answer to the next one. You probably already know for sure that the answer is 2, but there's another answer as well. And I'd like to think it's obvious also. Oh, yeah, sorry, bless me. Whew. Here we go. So 2x equals 4, okay? Right, so like absolute value of 2x equals 4. That means that 2x could equal 4, but here's what it also could mean. It could mean that 2x equaled -4. Same idea here. X could be 3, but x could be -3. We had 2 different answers. So 2x could be 4 and 2x could be -4. So x is equal to 2 and x is equal to -2. So one of the on-paper algebraic strategies that I have for this is to set the absolute value equal to the positive and negative of the other side, assuming the other side is positive, getting ahead of myself. So 2x equals 4, 2x equals -4, and I solve them both. And you could probably do that one in your head and you'd be fine. Most of y'all probably jump straight to that answer anyway. Now, I could also graph, and I'm going to graph the left side as its own function, absolute value of 2x. And this is basically everything you saw here, only the slope is going to be steeper. It's going to be 2. So up 2 over 1, up 2 over 1. So there's this steepness here. And the slope is -2 on the other side. There we go. And then I will graph the line y equals this side of the equation, y equals 4. And when I graph y equals 4, we have that. And I'm looking for the points of intersection. Could you do this on Desmos? Absolutely. Totally could. X equals 2, x equals negative 2. Those are the x values where we intersect, right? Okay, let's use the little algebraic strategy here and solve the next one, and even maybe the next one. And the next one gets a little bit tricky because people kind of blurt out the answer to this one in wrong ways. Okay, absolute value of x plus 2 equals 4. So here's what that means. And we're going to go back to the very beginning. If the absolute value of x is 3, then x would equal 3, and x could equal negative 3. So if the absolute value of x plus 2 equals 4, then x plus 2 could have been 4. Nobody is lost. Everyone's like, 2 plus 2 is 4. I hear ya. But we get in such a habit sometimes when you look at these answers and you're like, oh, 3 and negative 3, 2 and negative 2. Oh, 2 and negative 2. No, actually it's not. Because x plus 2 could have equaled negative 4, right? Because this stuff in this absolute value, the whole thing could have really been negative, but we just had to force it to be positive. So we have to consider, maybe it was positive already, maybe it was equal to a negative and we had to make it positive. So x is equal to negative 6. All right, so those are my two answers. So we could do that. If you were to graph this one, we'd actually run off the graph. I don't know if I said we'd do this one by hand or not, but if you did, you'd graph y equals the absolute value of x plus 2, and you'd graph, whoops, not in that color. We got to keep these things separate so they don't run together. Y equals 4, and we would graph those here. Let's go ahead and do the y equals 4 part. There's that. And then absolute value of x plus 2, well, that's a horizontal shift to negative 2. So there's that right there. And then, and so they intersect, these two functions intersect here and here. And like I said, this one runs off the graph, but it's at negative 6 and at positive 2. Okay, so here's the algebraic strategy one more time. Set the absolute value equal to the positive and negative. So then on this next one, a lot of times people will be like, oh, okay, I know what I'm doing now. And they're going to do this. Don't you do this. It's wrong. That's why I'm grabbing scrap paper. It's so wrong. Some people will be like, oh, well, x plus 2 equals 4 and x plus 2 equals negative 4. No, actually. Well, why not? Well, I'm glad you asked. Let's use the margin over here to figure this one out. I think we know the answer is 2, right? And we probably already know the other answer is negative 2, but I just want to show you that if you're going to use this little strategy right here, you can't just change the numbers, the sign of this number over here. It's not going to work. So here's the original problem, just for fun. And now, before I go any further, I need to get the bars alone. So I need to get the absolute value all by itself. So now we have this. Okay? We now have the absolute value of x equals 2. I could not just change this 4. I had to get the bars alone. Every problem so far had absolute value on one side all by itself, absolute value on one side all by itself, absolute value on one side all by itself. It was great. And so I have x equals 2, x equals negative 2. Okay? Now I could graph it the way I've done the other ones. Very quickly I will. Y equals, and not even having to move anything around, go back to the original. Y equals the left side, and y equals the right side, and graph them both. So here's 4, and here is absolute value of x plus 2. That's a vertical shift, so we're going to go up 2. It's a slope of 1, and slope of negative 1 on this side. And my graph got off a little bit, but we'll be all right. So there's a dot, there's a dot. This is where x equals negative 2, and this is where x equals positive 2, which makes sense. Okay? All right, the next one is kind of fun. Okay, it's a lot of fun. The next one, if we do this little strategy with the algebra where we say, oh, well, let's just take the absolute value of 2x plus 6, and we're going to just change the sign of that. Change the sign of 0? Yeah, right. That's lame. You can't change the sign of 0. It's just 0. That's all you got. That's all you can do with it. So in this case, you're only going to have one answer. 2x equals negative 6, so x equals negative 3. That's it. So when I said at the beginning you have the possibility of two answers, I didn't mean always, because sometimes you just have one answer. That's it. That's all I can do. So now you're probably like, well, why don't we graph it? Well, why don't we graph it? Let's graph it. Let's do that. So I'm going to let's switch colors just for fun. If I make this side, we'll do it purple. We'll stick with purple. Y equals absolute value of 2x plus 6. And we haven't technically really graphed it much like this, but I can factor a 2 out of both of those, right? So what I really have is y equals absolute value of 2 and then x plus 3. That's totally valid. I can do that. And one more thing, absolute value makes things positive. Well, this 2 is already positive, so we can just factor it out. So I have the absolute value of 2 and then x plus 3. All right, we know how to graph that. This is a horizontal shift of 3. So 1, 2, 3, negative 3. The slope is 2 on either side. There we go. 2 on this side, negative 2 on the other side. There we go. 2 and negative 2 are my slopes. And if I graphed the other side of the equation in green to be consistent with the rest of my notes, y would equal 0. Well, y equals 0 is simply the x-axis. And so if I'm looking for where they meet, that's it. And that's the only place. And that's where x equals negative 3. Okay, let's do the next one, graphing. And yes, you could Desmos all of these, but knowing these strategies is going to help you in so many other areas as well. So that's why I'm not just jumping straight to Desmos. We'll get to Desmos in another part of this lesson, the backside. So let's do absolute value of x plus 3 as one of the graphs, which we sort of just did. It had a different slope, but we can do that. So 1, 2, 3. There's this. There's that. There's that. Okay. And then the other graph is y equals negative 1. Okay, well, we're going to graph the line y equals negative 1, which is down here. There it is. And I want to find all the points of intersection. So let me get my red pen ready, and I want to find it. No, they don't intersect. Man. No solution. Okay, let's go back to the very top of the page. It's important to remember that absolute value represents distance on a number line, so it cannot be negative. And then they said absolute value of x plus 3 equals negative 1. Good luck with that. That's not going to happen. Absolute value will never equal negative. So from the very beginning, you could have looked at this and said, no solution. Now, if you want to use our little algebra strategy where you say, oh, well, this equals positive, it equals negative, and we'll solve them both. Yeah, sure, fine. But it gets shut down from the very beginning because absolute value can't be negative, so no solution.